All right, welcome back to the world of inequalities. We've been talking about solving algebraic inequalities for the last few days. Now we're actually going to go on to inequalities that are going to require you to use multiplication or division to isolate the variable. So our main focus today is going to be how to use the multiplication and division properties of inequality to solve inequalities. So let's get right into our rules. Now today we're going to have two rules, one associated with positive coefficients and one associated with negative coefficients. So the first one I'm going to underline with a positive right there. This is when we're talking about inequalities with positive coefficients. Positive is going to be a little different than negative, so let's focus, like I said, right now on the positive. I'm going to say it one more time, positive. The multiplication property of inequality and the division property of inequality, they both state that an inequality remains true if you multiply or divide each side of an inequality by a, once again, positive number. So like we said in the last few days, if we have an inequality where a is greater than b, so the number on the left is bigger than the number on the right, and I multiply both sides of that inequality by the same factor, whatever is on the left is still going to be the same as what's on the right. And the same is true for if I divide each side of that inequality by the same factor. Whatever's on the left is still going to be greater than whatever's on the right. And the same is true for if the value on the left is less than the value on the right and I multiply by the same factor on each side. Again, I'm going to have left is less than right. And if I divide, again, I'm going to have left is less than right. All right, so let's talk about how this looks when we're using numbers. If I look at the numbers 8 and 10, I know that 8 is less than 10. Now if I multiply both sides of this inequality by 2, I will have 16 and 20, which again, that brings down that inequality sign and keeps it the same as 16 is less than 20. So inequality sign stays the same. Same is true for if I divide. So I know 8 is still less than 10. But if I decide to divide both of those numbers by 2, I get 4 is less than 5, which is also going to retain the same inequality sign. Okay? So let's talk about what this looks like for negative coefficients. So this one is going to be really important for us to focus on. When you multiply or divide each side of an inequality by a negative number, the inequality symbol must be reversed for the inequality to remain true. So that word reversed, we can replace it with flipped or switched, whatever terminology is easier for you. So in other words, for all real numbers a, b, and c where c is less than 0, meaning that c is negative, if a is greater than b, then when you multiply a by c and b by c, do you guys see how the inequality sign switches there? Okay? So the same is true for division. It's going to switch the sign. And the same is true for if a is less than b. When you multiply by a negative, it's going to create an inequality where the left is greater than the right. In numbers, and we're going to focus on this a little bit more in the next slide, but in numbers, if 7 is greater than 1, and I multiply by negative 2 on each side, notice how the number on the left becomes less than the number that's on the right. So I started with the number on the left being bigger, but then it became smaller. The same is true for division. Negative 4 is less than 16 if I divide by negative 4 on each side, whereas I started with a smaller number on the left side, it becomes bigger. Okay, so let's talk about this on the next slide a little bit more. So what happens when you multiply or divide each side of the inequality statement by a negative? We know that the inequality sign is going to flip, and here's why. So I know that 2 is less than 5. I think you guys would agree with me. So if I take that 2 is less than 5 and I multiply each side of that inequality by negative 3. Typically, if you multiply something, it makes for a bigger number, correct? Which, whenever it's a positive multiplied by a positive, I now just have a bigger positive number. But when I multiply one positive by one negative, I get a negative number, or vice versa, or even negative by negative. So what happens is 2 multiplied by negative 3 produces negative 6. 5 multiplied by negative 3 produces negative 15. Now if I were to look at the absolute values of these numbers, 6 is definitely still a smaller number than 15. However, once those negatives come into play, negative 6 is a greater number than negative 15 because it is closer to 0 on the number line. So that inequality sign flips. Let's take a look at what this looks like for division. Let's say I start with 10 and 16. We know that 10 is less than 16. Let's divide each of these by negative 2. I now have negative 5 and negative 8. Well, which one of these numbers is bigger or closer to 0? That's negative 5. So if you're still kind of a little confused about that, let's take a look at what this looks like whenever we use negative numbers. I know that negative 3 is greater than negative 5. Now let's multiply again by a negative number. So I'm going to multiply by negative 2 on each side. That's going to give me positive 6, positive 10. Well, positive 10 is greater than positive 6, so again that sign switches. And let's try this one more time for division. I know that negative 12 is greater than negative 24. So let me divide each side of this inequality by negative 6. I'm going to get positive 2 and positive 4. Well, I know that 4 is bigger than 2. And again, the sign switches. Okay, so if you're still not believing it, try a few numbers on your own and see how you feel about that. You can definitely pause the video at this point and do that. But let's try some problems. So c divided by 3 is less than, c divided by 6 is less than 3. Let's just solve this. We're going to get lots of practice on the graphing later. We practiced graphing before. We're going to practice graphing again in class tomorrow. Today I just want to solve this. Well, before, if this was an equation, I would multiply each side of this by 6. Since it's an inequality, we're going to do the same thing. 6's on the left side will cancel out, leaving me 1c is less than 18. And that is my solution. Okay? Again, since this number here was positive, there were no changes, no flips. All right? At this point, I would think this is a great example for you to pause and try on your own. So let's get this solved. 5x is greater than 30. I'm going to divide by 5 on each side. In a minute, you may hear a bell ring. Ignore that. I'm going to have x is greater than 6. Again, since the number that I divided by on each side is positive, I don't have to worry about flipping my inequality sign. Let's take a look at one where I will have to flip. And for this inequality, we are going to graph. So for this one, we're going to solve it and we're going to graph it. So I've got negative 4x is less than or equal to 4. In order to solve this or isolate my variable, I know I need to divide by negative 4 on each side. So since this number that I'm dividing by is negative, I'm going to have to flip my inequality. So I can't forget to do that. So I know on this side I'm going to have x. On this side I'm going to have negative 1. That's a 1. My inequality sign flips. So I have x is greater than or equal to negative 1. Let me rewrite that 1 so it's a little bit easier to read. When I go to graph it, I'm going to scale my graph by 1s because this is a fairly simple number to work with. Closed circle at negative 1, and I'm going to shade to the right. Okay? So it's no big deal if you could just remember the rule that whenever you multiply or divide by a negative, you're going to flip. So let's take a look at this one. This one asks us to solve and graph. So again, if you feel confident enough to pause the video at this time, go ahead and pause the video. I'm going to need to multiply by negative 4 on each side to isolate the variable. I know negative 4's are going to cancel out, leaving me 1x, and I'm positive 20. Again, since the number that I multiplied by on each side is negative, that's going to flip my inequality sign. I'm going to scale my graph by 10s. open circle at 20, and shade to the left. So this should start to seem pretty simple and pretty reminiscent of solving equations. Again, I just have to remember the flipping. So 2 more examples and then we get to our problem of the day. So c divided by 6 is less than -3. This looks familiar. This should look like the first example that we did. The only difference is that in this case my inequality is actually including a negative number on this side here. But what am I multiplying by on each side? I'm multiplying by 6 on each side. That value is positive, so the question is, does our inequality sign flip or not? And the answer is no, because that 6 is positive, it's not going to flip. So I'm going to have c is less than -18. Again, they don't ask us to graph, so I don't have to graph that one. Alright, last example here. So think about it. Is this inequality going to need to flip? That's right, you're not going to need to flip because I'm dividing by a positive on each side, dividing by +2. It's going to give me x is greater than -7, final answer, and I am done. So that concludes our lesson. Here's your problem of the day, 2 problems. I'll be looking for 2 people to put these up on the board tomorrow. All right, have a great night.